Hi, Mark.
Hey, David.
How are you today?
Good.
It's been 1 week since we had that snowstorm. I still got a foot of snow in my backyard. Yeah, because it was last Tuesday that your internet went out and the snow. So are you sending me anything or?
No, I don't have anything today. But we've just been working with regular polygons and finding circle kind of things.
Finding the area of regular polygons using the Apothem?
Yeah.
Okay, should we do one or two of those?
Sure.
I've got another student that gave me the same information, so I kind of thought 1, 2, 3, 4, 5, 6. I want to make it a 7-sided. Yeah, that's not bad. It's almost a 7-sided regular polygon. What's the general equation for the area of a regular polygon?
A equals 1/2 ASN.
AS what?
N.
Okay, what's another formula for it?
I don't know. That's the only one I really use for it. But
S times N is the perimeter. In other words,
okay.
S is the side length times the number of sides gives you the perimeter. And I did see a problem in my book, my geometry book, that gave you a side. And when you have a side, it's actually a little easier to use this because you can come up with P so quickly. It also kind of helps you memorize this one because this is a little shorter, so it's easy to memorize. And then if you can remember that P is the side length times the number of sides, you're in business. Okay, so let's talk about the Apothem. First of all, on every regular polygon, we can draw as many triangles as there are sides. In other words, if I connect the center to each vertex, I get 7 triangles. What's angle 1? What's its measurement?
So,
Are all 7 of those angles the same?
yeah. So that's 7 times 180.
What's the measurement around the entire circle? From here back to there. How many degrees is that?
360.
Okay. So what's the measurement of angle 1?
51.4.
360 divided by 7?
Yep.
Okay. Now, let's take this triangle that angle 1 is drawn in, and let's draw it over here blown up so we can see what we're doing. And, more important, let's drop a vertical. Why? What's that vertical called?
The something.
Apothem. It's the A.
Apothem.
It's the little a from this equation. The Apothem.
Okay.
Okay? So the name of the game here is you're always going to need the Apothem pretty much to figure out the area of a polygon. So the first step is always to figure out the Apothem. Now, let's assume they have to give us a little bit more information. Let's assume the radius they give us is 2. Okay? And the radius is what these lines are called. In other words, if it goes from the center to a vertex, that's the same. If I drew a circle around that thing, that would be the radius of the circle. So these radial lines are called radiuses. but the one that goes perpendicular to a side is the apothem. So the trick is to figure out the apothem. What's that angle right there?
That one is set.
Call it 25.7.
Okay.
Half of this number, right?
Yeah.
In other words,
Okay.
these triangles are always isosceles triangles, and when you drop a vertical from the top vertex that's perpendicular, it always bisects that angle. So we know that each of these two angles is 25.7. Okay? Now the goal is to solve this triangle over here. By that triangle, I mean that triangle right there.
Okay.
You've had enough trig that you should be able to come up with a trig equation that's going to allow me to solve for A. And, for that matter, X, because I need to know the side length also. What trig function should I use?
For A or X first?
Either one, whichever you like.
You could use sine 25.7 times 2.
So the sine 25.7 equals x over 2, which means x is equal to 2 times that.
Yeah.
Okay. And that'll give us a number in our calculator. You want to put a number on that just so we don't get confused?
Sure, let me get one good one.
It's going to be a number slightly less than 1. I know the sine of 30 is 1/2. Sine of 25 must be 0.4.
Yeah.
So what's x here?
0.4, times 2 is, 0.85.
Okay. So let me label x down here. That's 0.85. What's A?
A is...
What's the formula for A?
Let me think.
The way to do this, Mark, is to always think a trig formula. In other words, I didn't really like what you did there. You did 2 steps in one. Trigonometry is all about ratios. So the very first thing we should be able to do is figure out which trig function of this angle equals A over 2. And let's start out like that. So the cosine of that angle is equal to the adjacent, the apothem, divided by 2, which makes the apothem 2 cosine of 25. So you got to the right answer. It's just you did it in 1 step instead of 2. I want to make sure you're totally clear as to how we do these. So let's put a number on the apothem also.
Okay. So we could use...
in other words, put this into your calculator, come up with a number for that.
All right.
And in your calculator, you can do 2 times cosine 25.7 end paren, and it'll give you one number.
So it's 1.80.
Okay, so we'll put a number there, 1.8. Now, do we have everything we need there? We have little a,
Yeah.
that's 1.8. What's the side length?
Side length is 2. No, 0.85.
Remember, that's only half of that triangle. In other words, the original triangle is an isosceles triangle. Remember, it looked like this? And it's all we figured out was half of it. Yeah. Side length is 1.7. Number of sides?
7? 6. No, 7, I guess.
7 sides. And that's the way you want to do every single one of these problems. Exactly like that. And it's because you can have all kinds of sides. You can have 11 sides, 13 sides, 14 sides. It's rare that this angle that we're looking at there is ever going to be a nice angle. If you have a 6-sided hexagon, then this angle ends up being exactly 30 degrees. And you could even solve that triangle without using trig. You know, if it's a 30-degree angle, then that's a 30, 60, 90. We know how to do 30, 60, 90 triangles without trig. But I'd actually rather see you do all of these using trig, using this exact method, even if it's a 30-degree angle. Let's do one more using 30 degrees.
Okay.
I'm going to erase that. So what's angle 1?
Angle 1 is, for 6 sides, angle 1 is 26. Isn't that just, wait, sorry.
Just think how
60
we do it before. Right, exactly.
Is it 60?
Uh-huh. So this whole angle is 60 degrees. What's the half angle here?
30.
Okay. Now I'm going to make the radius 1. Okay. And now let's solve this. So we've got 2 things we have to solve for. Remember, x is only half of the side length. I actually could make this, instead of calling it x, I could call it s divided by 2. But I tend to think that's actually more complicated than this method. So we'll call that x, which is just that side length, and we'll call that a, the apothem. Help me solve for x and a in any order you want.
Could we do sine 30 to find x?
Equals what?
Sine of 30 is 0.5.
No, when I say what, I mean when you take a trig function of an angle, you get a ratio as an answer.
Okay.
So put something over something.
Oh, I have to use
In other words, use SOHCAHTOA to give me that answer. SOHCAHTOA. Just because it reinforces your trig. So without knowing what the sine of 30 degrees is, if you didn't have a calculator, from this triangle, what's the sine of 30 degrees equal to? What's opposite over hypotenuse?
Sine, right?
Sine is the proper trig function. We don't want to use tangent. But what is
So
the
it's
sine of 30 degrees equal to looking at that triangle? What's the opposite? What's the hypotenuse?
well, it's 30, 60, 90 triangle.
Don't think of that, though. For a moment, what I want you to tell me is what that means. What I've circled at the top. What does sine mean?
Sine opposite hypotenuse.
Opposite over. There's always a hidden over in there on all three.
Okay.
That's also over, and that's also over. And that's what gives you a ratio as an answer. Okay? So, what's the sine of 30 degrees based on everything you see in that triangle? What's the opposite equal to?
Sine of 30 is...
What's the opposite side to? What's the opposite side to the 30-degree angle?
X over 1.
There you go. That's what I'm looking for. Always a ratio. In the last problem, it was 2, so it was x over 2. And that's why our x turns out to be 2 times the sine of 30. I changed it to 1 in this case. I'm still wanting to emphasize ratios. Okay, so now what is x equal to? Because you can look that up in your calculator. Go ahead.
What do you mean? Okay, x is 0.5.
Okay. Now I can label x, and I'm halfway towards coming up with the s, side length. Now let's do a. What's the complete expression in trig language to figure out a? Start with the trig.
Cosine 30
equals what?
Equals a over 1.
Good. Which means a is equal to the cosine of 30. What's that number?
Let me look. Cosine.
Square root of 3 over 2 should be about
0.87.
0.87. Okay. So that's 0.87. So we've solved for the two things that we always have to solve for in these problems. Now, the apothem is what?
The apothem is 0.87.
Side length is what?
Side length is 1.
And the number of sides?
Is 6.
So you just have to do that multiplication and to come up with the answer. Now, they're not always going to give you the radius of these things. They may give you the apothem and not give you the radius, or they may give you the apothem and not give you, in other words, they only really have to give you one thing. In each of these previous cases, once you knew that angle and this radial length, you were able to figure out A and S. Well, let's change the problem slightly. We'll leave it as a 6-sided figure, only this time we're going to make that thing 6. We still want, it's a 6-sided figure whose side length, and let me not use 3, let me use 5. Side length is therefore 10. So the only thing we know is that we have 6 sides and we have a side length of 10. What's the area?
Can we use I think there's a different equation for this one.
Don't need a different one. In other words, the key is always to figure out the apothem.
Okay.
Okay? Notice that I don't need the hypotenuse for this area formula. This area formula needs an apothem, a side length, and a number of sides. So in this case, you know the number of sides, you know the side length, so all we need is the apothem. So what trig equation will allow me to figure out the apothem based on this triangle there?
Cosine. Cosine 30 equals a over, didn't you have 1 there before?
Yeah, but I changed it for this. In other words, we don't know what this length is. The only length we know is that 5.
Okay, so we can do...
Which trig function relates
We can do tangent.
There you go. In other words, you always have to figure out which trig function relates the two variables that we're looking at, or two numbers. Okay? Before, when we had an x there, notice tangent wouldn't let us solve for anything. Tangent would be x over a, but that's two variables, and now we can't solve for it. In this case, the only variable is a, and the only other information is the opposite. So what's the equation?
Tangent 30 equals a over 5.
What's TOA stand for?
5 over a, sorry.
Okay, that's all right. Solve that. This is a little harder to solve algebraically.
That was, I got 2.8 or 2.9.
Not sure what the answer is. Solve this algebraically for a without finding out the tangent first. Just so I know you.
Okay.
What's the first step in solving?
The tangent.
Don't convert that yet. Leave it as tan of 30 for the moment.
Okay.
We know that's a number. At the moment, I don't care what it is. What I'm looking for is to make sure you can do the algebra to solve that for a.
You gotta multiply a on both sides so that it cancels out.
Now what?
Now you solve it?
Now you divide by tan of 30.
Okay.
As long as tan of 30 is a number, and we know it is, then I can get this far, and it's better to get this far. In other words, the moment you pull out the tan of 30 on your calculator, you're rounding it off. You don't ever really want to do that before the end. Once I get it to this point here, now I can put it directly into my calculator as 5 divided by parentheses tan of 30, or even probably without the parentheses. And you would get an answer. What is that number? You probably had it before. 1.8?
8.7.
8.7. Okay. Now, A, you just figured out it was 8.7. What's S?
6.
Look at the picture. S is the side length.
S is 10.
And number of sides?
6.
Okay. You'd catch that mistake if you were taking a test, because the moment you put 6 in there, you'd get to N and realize that you got the wrong 6. Okay? So the only thing that made the algebra tougher here was the fact that your variable was in the denominator, which means you had to do a couple of steps first. Before, our variable was in the numerator, and with one step, we could do the algebra. This is a 2-step. You have to multiply by a and then divide both sides by tan of 30.
Okay.
So this problem was actually easier than the others. I only had to figure out one thing here, a. In the other case, I had to figure out this length that's now 5. We had to solve for that and a in order to fill in everything into this equation. So a lot of times they may only give you one thing. And in fact, well, we don't need to do it today, but if you're still working on regular polygons Thursday, we can do one more. And that's where they give you the apothem and nothing else. Notice what happens. I'll just try to do it really quick here. I won't do all the math. Let's say this is the problem. In other words, they don't give us the radial. They don't give us this. They don't give us the side length. So if they gave us this only, now the only thing I have to solve for is that, right?
Mm-hmm.
Because if I solve for x, I'll have the side length. I know the apothem already, and I know the number of sides. So again, we're going to have to use tangent. Only in this case, it would be the tangent of 30 degrees equals x over 5. That's easy to solve. Multiply by 5. There's your x. And now, once you have x, you're going to double it to get s. Always remember that you got to double it. So I'm almost hesitant to draw this thing that way as opposed to drawing it like that.
Okay.
Because that's probably the easiest mistake to make, is once you come up with x, not doubling it to get the side length. But all regular polygons, that's about the only three ways that they can present a problem to you. Is they can give you the radial, they can give you the side length, or half the side length, or they can give you the apothem.
Okay.
Okay? And with any of those three, once you figure out what that angle is, then you can use trig to solve for everything you need.
Okay.
Okay? All right, Mark. Good session on regular polygons. I will talk to you Thursday.
All right. Thank you, Dave.
You're welcome.